So in the last video we looked at how there are many numbers which can't be stored completely accurately in binary, and indeed can only be stored to a certain degree of accuracy depending on the format. So we're just going to quickly summarise here and compare the advantages and disadvantages of fixed point and floating point forms in terms of the range, precision and the speed of calculation on binary numbers. So first let's look at the range. Well, with fixed point, the range all depends on the position of the binary point. The more digits to the left of the binary point, the greater the range. When we look at precision, again it all depends on the position of the binary point. The more digits to the right of the binary point, the greater the precision. Of course, in both these situations, you are sacrificing range for precision and vice versa. In terms of calculation speed for fixed point, as fixed point is simpler to calculate, processing speeds tend to be relatively faster than with floating point. Let's look at floating point now. In terms of range, we can easily represent a very large numbers and very small fractions with floating points. The more bits that are used for their exponent, the greater the range will be. For precision, the more bits used for the mantissa, the greater the precision will be. Again, there's a trade-off here between range and precision. In terms of calculation speed, the floating point first has to be moved, and obviously there's extra steps involved in the processor to do that. Even with modern CPUs that have access to hardware floating point circuitry, it's still going to take longer to calculate and process a floating point number compared to a fixed point number.